You're rolling, Professor.
Yes. Yes. So about Duncan's solution. So we discussed Duncan's 1937 result. So that is d of x d2w dx squared plus p critical w equals 0 for buckling of a simply supported column. He obtained the following. D of x equals 1 minus 3/7 x over L squared d sub O. And then W of x equals some A 7 x over L minus 10 x over L cubed plus 3 x over L in fifth power. And P critical equals 60 over 7 d sub O over L squared. You remember this, I hope. We did discuss this topic. So just a reminder that prior to him, solutions were obtained by Euler, 1759, and Engesser, 1899. This guy, 1937. So one of the students asked, how did he get the solution? Do you remember who asked?
Was it me?
Yes. Yes. So that was his question. So answer was, of course, I don't know. Why? Because he did not write. He did not elaborate. Okay? He did not elaborate how he got the solution. So therefore, we cannot answer how he got it. Now we will answer a different question. Another question. How to obtain Duncan's solution? By a method that I described past time. So that is a question. Duncan just wrote all these formulas. So first of all, let us concentrate on the differential equation. So that is d of x d2w dx squared plus pre-critical w equals 0. So it's always good to work with non-dimensional coordinate. So that is psi, which equals x over L. So then x equals psi times L. So I substitute this here, I get d of psi here, and then d2w L squared d psi squared plus p critical w equals 0. Or we multiply everything by L squared, we get d of psi d2w d psi squared plus p critical L squared w equals 0. So let us try to pose this as an inverse problem. As I did past time. So we say find d of psi compatible with a postulated buckling mode w of psi equals psi of psi. Psi is a given function. So what I'm saying is I will give only psi. I will specify only psi. I will not specify d, and I will not specify buckling load. I will just specify psi. And let us try if we can get the solution. Okay, so this w equals psi and equals, say some a, 7 psi minus 10 psi cubed plus 3 psi in fifth power. So we know only this. Okay, so then it is easier to I cannot guess three things, but psi I can guess. I cannot usually guess psi and d of psi and p critical, but psi of psi is easy to construct. Yes, it should satisfy only boundary conditions, so it's a trivial task for us. Okay, now I have my differential equation, d of psi, d2w d psi squared plus p critical L squared w equals 0. So then, because w equals psi, this becomes d of psi, d2 psi, d psi squared plus p critical L squared psi equals 0. Okay? Now this then psi is a fourth order polynomial, no, fifth order polynomial. Fifth order polynomial. Okay, we see here psi in fifth power. Now then this guy will be third order polynomial. So therefore this guy must be second order polynomial. So we are not guessing, okay? We are reasoning. Together. I think this phrase, this first scientific phrase, statement, let us reason together, so belongs to prophet Isaiah, 5th century before Common Era. Okay, we are reasoning together. Of course, one can sit and reason by himself also, but it's always good to reason with other people because other people may see the mistakes that I'm making. So you can see my mistakes and stop me from making these mistakes naturally if I'm doing. Okay, so let us now deal with this. So psi, I will rewrite this psi. So psi equals 7 psi minus 10 psi cubed plus 3 psi in 5th power. I calculate psi prime equals 7 minus 30 psi square plus 15 psi in 4th power. Psi second derivative equals minus 60 psi plus 60 psi cubed, or just 60 times minus psi plus psi cubed. Now d of psi, second order polynomial, b0 plus b1 psi plus b2 psi cubed. You see, I will just show you the way how to obtain the solution by Duncan. He did not tell us that this was a way, or maybe just guessed. So let us multiply then this. So d of psi, psi second derivative, that equals b0 plus b1 psi plus b2 psi cubed times 60 times minus psi plus psi cubed. This equals 60. Okay, now let us say it again. Here should be squared. You see, that is what let us reason together. Otherwise, I may continue and. Okay, so this b2 times psi cubed will be b2 psi in 5th power. Then b1 times psi cubed will be b1 psi in 4th power. Then let us see what happens with psi cubed. Psi cubed, so this term must be multiplied by this, minus b2 psi cubed, and b0 multiplied by this, plus b0 psi cubed. Now psi square. Psi square can be obtained by this b1 times this, minus b1 psi square. And then psi in 1st power, minus b0 psi. Okay? So it is a second term. That is the first term. Second term will be P critical L square psi. So that is P critical L square, and psi itself is 7 psi minus 10 psi cubed plus 3 psi in fifth power. Now we would like to add these two things together. We add these things together. And we obtain, look please. So, yes. So it will be 60, I will just rewrite everything. B2 psi in fifth power plus B1 psi in fourth power plus minus B2 plus B0 psi cubed minus B1 psi square minus B0 psi plus P critical L square 7 psi minus 10 psi cubed plus 3 psi in fifth power must be 0. Okay, now we would like to say that, let me rewrite this as yes. So we don't have anything psi in zeroth power. We don't have any terms. There is nothing, just constant. So that is, so psi in first power. So this is fifth, fourth, third, so that is minus 60 B0. Okay, psi. Then plus P critical L square times 7 equals 0. So from here we get P critical equals 60 B0 divided by 7L square. I think nice, very nice. It already looks like his solution. Still we have here B0, so but we will get this. Now psi in second power. So here is minus 60 B1. And here there is nothing. So equals 0. From here B1 equals 0. Now psi cube. Psi cube will be like this. 60 minus B2 plus B0. And there is here minus 10 P critical L square. Yeah, psi cube. This equals 0. So what we get here is as follows. Yes, so let us substitute here this expression. So we get 60 minus B2 plus B0 minus 10 times P critical will be 60 B0 7L square, and here is L square, this guy equals 0. So this and this L squares are canceling each other. So this 60 and this 60 will cancel each other. Yes, so we get minus B2 plus B0 minus 10 B0 over 7 equals 0. Or minus B2 equals 10/7 B0 minus B0. So that is 3/7 of B0. So B2 equals minus 3/7 of B0. Okay, that we got from Xi cube. Now Xi in fourth power. Xi in fourth power, then this Xi in fourth power, 60 B1. But there is nothing there, so this is 0. And we again got B1 equals 0, which is the same like here. Now Xi in fifth power. So that is 60 B2, and then plus P critical L square times 3 equals 0. So this goes there. We don't need any more. 6. So from here we get B2. B2 equals minus 3 PL square divided by 60. Okay, so I will substitute now this P. Minus 3 60ths, and then L square, and P equals 60 B0 divided by 7L squared. So L square and square are gone. 60 and 60 are gone, which equals minus 3/7 B0, which is the same as before. For Xi cubed. Okay, let us summarize the results. D of Xi equals, what is D of Xi? B0 plus B1 Xi plus B2 Xi squared. So this is B0 stays as it. B1 is 0, we said. And B2 is minus 3/7 B0. So, and then it is Xi squared. So then B0 can be taken out. 1 minus 3/7 Xi squared. So let us summarize. P critical equals 60 B0 7L squared, and D of Xi equals B0 1 minus 3/7 Xi squared. So here too we obtain infinite amount of solutions. Since B0 is arbitrary, but arbitrary positive number. Okay, there are many solutions. You can substitute for B0 whatever you want. We got infinite amount of solutions. Now, Duncan's writing. How to obtain Duncan's writing? His writing. So it's very simple. Calculate D of 0. D of 0 equals B0 So therefore he actually, so he denotes this as d sub 0. But I think what is written here is neater because it talks about infinite amount of solutions. But otherwise, it's okay. D sub, then we get P critical equals 60 D of 0, 7L squared, and D of psi equals D of 0, 1 minus 3/7 psi squared. Had he said that D sub 0 is arbitrary number, then he would have said that there are infinite amount of solutions. But he was not thinking in terms what we did here. So therefore he just guessed this solution. At least we obtained here how to, so to say, guess intelligently. So that was our idea here. How to guess intelligently, so to say. Okay. Any questions? 40. 40 will have somewhat provocative title, Intelligent Design. Now that we know how to guess intelligently, guess, of course, should be taken in quotation marks because we actually did not guess, we obtained. We did derivation intelligently. We can also design intelligently. Now, how to design in buckling? So that's the question. Answer, how to design in buckling? What does it mean, design in buckling? I don't want my structure to buckle. So one can actually think, I don't want structure to buckle. That is what my design is. I don't want buckling. Bad statement. Why? Because buckling does occur. Buckling load is P critical equals 60 over 7 D sub 0 L square. What does it mean you don't want buckling? If the, there is this buckling load which is written here. So how can you cannot possibly avoid buckling. There is an expression for the buckling load. So we have to modify our desire. This reminds me of a son who, at some time, there were no emails, telephones were also very scarce. So son sends a telegram to his parents. Send me $100 ASAP. So parents respond, no, we send $10. There was a misprint in the telegram. In your telegram. Okay, so parents are modifying, so to say, a wish of their child. So we send you $10. Okay, So this is a modification, so to say, of desire. So 8. So I don't want my structure to buckle. So that starts exactly the same. But here we have to add, prior to a load P sub 0. That is what I don't want. See, I want, if buckling occurs, it to occur after P0. Like a person cannot possibly say, I don't want to die. I mean, we know that that is not a possible wish. But he can say, I don't want to die until age of, say, 100 years. That hopefully is a possible thing. Maybe a person should modify his behavioral patterns, etc., choose proper parents genetically, etc., then maybe that is possible to achieve. So that means that we want not to buckle until P0. That means that P critical, which equals 60 over 7 d sub 0 L square, must be greater or equal than P sub 0. Okay, that means that d sub 0 then must be greater or equal than, it's very simple, 7P0 L square over 60. Okay, that is intelligent design. I'm designing in such a manner, I'm choosing D0 bigger than 7, and that is P sub 0. That is what I want. I want not to buckle prior to P sub 0, times L squared divided by 60. Then P critical will be greater than P sub 0. Okay? That is what intelligent design would be. This is also called, such an intelligent design is called tailoring. We are tailoring the system to what I want, to our desires. As it were, our system to our goals, or to our goal in this particular case. So here we would like to ask one more question. See, I worked yesterday on this problem because student asked why and how. I want to know now. So actually every course is tailored to the students. If you don't ask, then you don't get it. However, if someone asks something, then he may get an answer. I mean, if I will spend time and maybe we will think together, maybe there is an answer. But usually course is very student tailored. Question, another question that you could ask. How was psi of x obtained, or psi of psi obtained? So that is a question, because I started with psi. He gave everything. Okay, Duncan gave d of x, w of x, p critical. So he gave everything, absolutely. So I said, you know what, no, forget everything. Let us specify only w of x. That is enough. It is enough to ask w of x. That is sufficient. We don't need to give everything. The rest will come out by itself. Okay? But we will pay attention that it is a polynomial, etc. We will tell. So, okay, so so this psi equals 7 psi minus 10 psi cubed plus 3 psi in fifth power. So let us calculate first derivative. 7 minus 30 psi square plus 15 psi in fourth power. Psi second derivative, minus 60 psi plus 60 psi cubed. Psi third derivative, minus 60 plus 180 psi squared. Psi fourth derivative equals 360 psi. So that means that if I take a beam and the loading is 360 psi, so beam under such a loading, okay, will have a displacement proportional to psi. Okay, 360, okay, just psi can be also taken. Or anything multiplied by psi, some constant multiplied by psi. Now this gives me idea for the following homework. Okay, let us work together, in the beginning at least. Homework set. What is the set number? $21. Okay. Consider a clamped beam under a loading. So let us say beam, so it is clamped, and this is clamped, and the loading is 360 psi. So then will be d4 psi, d psi in fourth power. Imagine loading equals 360 psi. The rest is 1, or whatever. This is just, I want to obtain psi only. So then psi third derivative will be 360 psi square over 2 plus C1. Psi second derivative will be 360 psi cubed over 6 C1 psi plus C2. Psi first derivative will be 360 psi in fourth power 24 plus C1 psi square over 2 plus C2 psi plus C3. And then psi equals 360 psi in fifth power divided by 120 plus C1 psi cubed over 6 plus C2 psi square over 2 plus C3 psi plus C4. Now, this guy equals 0, of course, because psi at 0 equals 0. This guy is also 0, because psi prime at 0 equals 0. So obtain C1 and C2 from the demand that psi 1 equals 0 and psi prime at 1 equals 0. That is one thing. That is part 1. Then second, consider buckling of a clamped beam. Okay. Okay, so that will be d of psi d2w d psi square plus p critical L square w equals 0. Postulate w equals psi. Find d of psi such that this is possible. Say it again?
This is a beam or a column based on the orientation.
What does mean orientation? Okay, in buckling, everything, I mean, it is beam equations, but called column. Clamped column, okay. Okay, fine, thank you. Thank you. You're right. Find d of psi such that is possible. Try to use Maple or MATLAB, or no, if you don't like all of these, then hand. So that was 2. Now 3. Consider clamped simply supported beam under the loading 360 psi. Find psi. It is clamped simply supported. 4. Buckling of clamped simply supported column buckling of clamped simply supported. Find d of psi. I will assign you one more because you are great guys. So it is clamped simply supported column. Okay, maybe we will assign homework later, but now I will continue a bit, or maybe I will assign now. 5. Clamped free beam. Yeah, clamped free column. Let us start with column, not beam. Now, in the clamped free so that is a column, so that is in buckling. So it is P critical. So if it is clamped, so here W equals 0, W prime equals 0. Second, at this point, naturally there is no bending moment, mz equals 0. Now, but shearing force is not 0. So that is P critical. Shearing force is a force that acts like this. That is a shearing force. So then we should write down, look please, Vy, that is this Vy. But now this plus P critical dw dx, this must be 0. Or EI w third derivative plus P critical W. First derivative must be 0. Now we want to find some psi. So psi will be like this. Look at this. A sub 0 plus A1 psi plus A2 psi square plus A3 psi cubed plus A4 psi in fourth power. Let us talk about fourth order polynomial first. And this guy will be 0 because of boundary conditions. So this equation will be called like this. Look, please. D3W d psi cubed L cubed EI plus P critical and then dW L d psi equals 0. Now, I said EI, but EI, sorry. This should be, this is all wrong. I'll explain you why it is wrong. 12. Okay, Vy equals d dx of E high d2w dx squared. So in this case, this is d of x. So therefore, we will have actually d L d psi, d of psi, d2w L squared d psi squared, plus P critical dw L d psi equals 0. So boundary condition will be, look, d psi, d of psi, d2w d psi square, plus P critical L square, dw d psi. So now actually here will be, look, this guy is this B0 plus B1 psi plus B2 psi square. This guy is unknown.